Hello, and welcome to Sterling and VMware's Power Block session. I am Megan Moore, Sterling's VMware Partner Business Manager. We know your time is valuable, so we want to say thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please, Billy. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Security is of the utmost importance at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases you will find at the end of the demo. For questions during the demo, please put them in the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to demonstrate NSX-T Identity Firewall with Horizon VDI.
Awesome. Thank you, Megan, for the introduction. So my name is Billy Downing. I'm a cloud architect here at Sterling in our strategic services organization. And today what we're going to talk about is, like Megan mentioned, NSX-T with Horizon, and specifically how we can utilize NSX-T's identity firewall to secure your user base when they're utilizing Horizon as your VDI solution. So we're going to start out and just get kind of level set with the 2 products and what they are and some of the main components of those 2 products. So we'll go over Horizon. What are some of the things that we'll be seeing as we log into the environment? Then we'll go into NSX-T and do the same kind of overview. And finally, we'll look at, what are these things actually and how do they work in tandem with each other, and how do they coincide with my user identity based on an Active Directory account? And how can we give the NSX firewall a little more context to help lock down our Horizon workloads from a user perspective? Once we go through all of that, we'll go through an actual demonstration so I can show you how the environment actually would look if you were to employ this type of a solution. And we'll talk about some of the use cases and go through an example of applying firewall rules on a user basis to halt traffic from, say, server infrastructure or things of that nature. So to start it off, we'll talk about what are the different components of Horizon. So on the left-hand side, we have a generic diagram that was created by VMware and TechZone. The Horizon TechZone is a great resource for material on Horizon specifically. But the main components that you probably will come across as far as what makes up a Horizon infrastructure, aside from the actual vSphere environment that is deployed on top of, are going to be starting with up top, you'll have your Horizon clients. So these are any of the machines or user devices that are actually accessing a VDI instance or a virtual desktop on your data center. So this is going to be anything like a cell phone, a laptop, a desktop, a thin machine, anything that can either access the connection server or overall access your environment or instantiate your virtual desktop through either the web-based solution or a thick client you can deploy on the machine itself. Next, what we have is Workspace ONE. I won't be demoing Workspace ONE today, but it is a component that comes along with Horizon, and that's used as a self-service catalog of applications for virtual desktops, as well as your web-based access to those virtual desktops and RDP session hosts. What this acts as is a single sign-on entry point that allows an administrator to control access to resources that are behind the Horizon gateway. And overall, it's just kind of that initial point of security invocation of who and what can access resources in the Horizon environment as a whole. The next going down the line is going to be the unified gateway. The unified gateway acts much like a proxy for users who are connecting to your Horizon environment from perhaps somewhere external, or if you want to add another security element from internal users as well. Typically, a Horizon unified gateway is going to be deployed in a DMZ and given a public IP address to allow it to proxy connections from the greater internet or from your intranet if you have, silent sites or sites that aren't connected to the internet themselves. It just gives you a gateway to proxy those connections into the Horizon environment through the actual gateway itself. Finally, we have the Horizon connection server. This is kind of where all of these two components before this kind of culminate to. This is where the users actually connect to the connection server that then presents them their options of what they're allowed to access from a resource perspective. So this means, and we'll see how this looks when I actually log in to our connection server and I'm presented with, different sites that I'll be able to build desktops in, and those types of resources. Then the connection server is actually what facilitates the creation of those desktops and linking everything together as a whole. So overall, what Horizon is attempting to do here is provide a VDI solution, as a whole, just by itself for your entire environment. So, that allows you to just provide another tool in your tool belt to provide remote access into your environment. And the benefit of this, and how we're going to see in a second how that it ties in with NSX-T, is providing a virtual desktop for users to consume in order to access important resources in your data center. That means that you control the desktop that they're actually using, not just from a perspective of, you give them, you lock down them from not having administrative rights, but you actually dictate the image, you control all of the updates. You don't have to worry about, users rebooting every night, things like that. And as we'll see in a second, you can integrate that because it's now a virtual machine on your vSphere environment. You can use NSX to add a little more context to the security policy you set on those desktops themselves. So the next component that we're going to look at is NSX-T specifically. And if you're not familiar, NSX-T is essentially a software-defined network that creates a unified fabric for not just vSphere, but also Linux hosts as well. And it provides basically the capability to employ all network functions from security to any sort of services that are provided by a standard hardware-based network, puts it down into software and puts those functionalities on top of transport nodes. So going around this little circle here of what makes up NSX-T, we start with the control and management plane. So NSX-T is actually built in a centralized fashion where you have a highly available and scalable cluster node or cluster of management nodes. Those nodes are 3 virtual machine appliances you would deploy in your environment. And they'll actually provide the command and control for the entire NSX-T fabric as a whole. So they'll provide the control plane management as well as your API and UI access to configure everything as a whole. So what this really does is allow you to create a centralized control mechanism for your entire environment. So you have one point of security invocation, service invocation, and whatever else is needed for your entire fabric across a single site or perhaps multiple sites if that's an environment you're deploying. The next aspect of NSX-T is the data plane. And this is unique in a sense that the data plane and control plane are not merged into a single box or a single entity because the data plane is a distributed based architecture. Meaning that outages and such like that to your control plane do not necessarily affect your data plane. The data plane is actually distributed across the hosts that are actually running NSX themselves, which are referred to as transport nodes. And in our case, that'll be the actual ESXi hosts themselves. So once you enable a vSphere cluster with NSX-T, it's going to deploy several VIBs and other components that enable those ESXi hosts to run network functions directly on the box themselves. And that includes security as well as the services required. So moving on, if we talk about security, for example, since we're going to be deploying our data plane in a distributed way, each one of these hosts are going to have their own implementation of the east-west firewall for, microsegmentation or east-west kind of traffic that is going to be within your data center. It'll also allow these hosts to have north-south firewalling capabilities that are, all integrated through NSX directly on the hosts themselves. And so what that really means is that as your environment scales, compute, storage, network, things like that, these services will scale linearly with those hosts as you add them. So it kind of removes that bottleneck that you might have in your environment today where everything is going through a centralized firewall. If you have one single firewall that everything is flowing through, as you increase compute load, increase virtual machine capacity, you have to then manage that firewall separately to increase its size so it can keep up with demand. In this distributed architecture or distributed data plane type of way, NSX-T allows you to do that simultaneously. So as you add more hosts for compute for your actual resources, you're simultaneously adding resources for the network services and the security services that are provided by NSX-T. Other security components that we'll take a look at with this is deep packet analysis or URL inspection, as well as IDS, IPS. You have visibility that is everything going through that. You can export NetFlow or IPFix tables from NSX-T. You can also manage everything through a centralized API or use a UI as well. And finally, for NSX-T, it provides all the services that you'd expect out of a normal network infrastructure. And that includes, you can build VPNs, you can do NAT, DHCP, network overlays using Geneve tunnels, routing on hosts, as well as layer 2 switching across, in addition to load balancing. And we'll actually take a look, we won't focus on it, but we'll do this next week or in our following series of this power block. We'll talk about the NSX Advanced Load Balancer, which we'll see today, but we won't focus on. So overall, NSX-T is just the general solution that we're going to be deployed to ensure that we're kind of completing that entire software-defined data center model, so that our entire network is now built as software objects directly on our hosts themselves. And we have a consolidated architecture where our ESXi hosts are providing, storage through vSAN, compute through vSphere, and now network through NSX-T. So we have this completely converged infrastructure. We're going to run our VDI infrastructure on top of that. And then because everything is so implemented together and integrated, we'll see how we employ all these things in a single holistic solution. Okay, so how do these two things work together? So say you're looking for a way to deploy VDI, or you have VDI in your environment today, and you're running into issues of how to secure user network access. Once they actually build out that virtual desktop, how do you control where they can go? So using NSX, we're able to sync this directly with an Active Directory environment. Once we, and the steps are kind of here listed, the three as they go along. Is first, you have to identify who the user is. So when a user initiates a connection to a VDI desktop, the UAG, or the Unified Access Gateway, as well as the connection server, are going to identify who that user is to ensure that they can even access a desktop in the first place. Once that user logs into a desktop and they're in their VDI environment, those VDI desktops are going to have VMware tools running on them, and through those tools, there's a thin agent applied to that is the NSX guest introspection. This is going to go ahead and tell NSX, based on the user logged into the environment, what the username actually is. Because NSX is syncing with Active Directory, now NSX knows the user that's running on the VDI, as well as what groups or associations that user has in your Active Directory environment. The next step is, now that NSX has this context, so it has the idea of who is this and what machine are they on. So now it links user identity to IP address. You can then use those groups you create based on Active Directory in the NSX environment to then create groups of administrators, groups of users, groups of specific power users, and you can start identifying what are the different user bases you have and what are the actual access they require. So by employing this, you're able to use this in a way of least privilege access. So every user can have a separate policy to determine wherever they log into in your VDI environment, exactly what they can access. Finally, we have our policies created, we have our users identified. The final step is to actually do something with that information. And so what NSX is going to do is allow us to use those groups that we created in NSX based on users and actually apply them in the distributed firewall for all east-west traffic flow. So what this means is that when a user logs in, they're identified, and a policy fits their user account based on the group they're in. The distributed firewall will then employ these a list of rules that are applicable to that user directly to the ESXi host for which the virtual machine is actually instantiated. So what that means is you have on-box firewalling per user, regardless of the actual desktop or where they live. The policy will live with them as long as they're on the NSX-T fabric. So if you have multiple sites, if a user chooses to log into one or the other, the policy will follow them regardless of where they are. So this really removes the need of having to manage subnets and create firewall policy based on subnets or other things that identify not the application or the actual thing you want to be identifying, but by identifying infrastructure, which is an issue in a lot of environments that I've worked with personally. It gets tough to have to manage IP address subnets in firewall rules to understand what can access what. Then you have a failover event and you have a new IP scheme and you have to create all new rules and make sure you understand where your subnets are. When at the end of the day, the goal isn't to know where subnets are. The goal is to understand where users are, because users are the base component that we can secure to ensure we have a reliable and secure infrastructure and everything is going great with the policies that we want to invoke. So this is kind of a rough sketch of the environment that we're going to take a look at in just a second. Starting from left to right, I am using Avi. And I do have a multi-site deployment. We're going to focus on a single site here, and we're not going to dive into the Avi. There's a following power block, I think 2 weeks from now, that we'll dive into the Avi side of this. But for now, we're kind of focusing on from Horizon VDI over to the NSX-based security. So we have multiple sites. We have Avi fronting this with GSLB. I'm going to play a user logging into a desktop at a GSLB provided address. I'll connect to one of the sites, build up a virtual desktop, and then we're going to test how can I actually, based on my user account from an NSX perspective, how do I lock down, myself from being able to access different assets across the environment. Okay. All right, so here, what I'm looking at right now is the NSX-T UI. So this is NSX-T 3.1. And what I have right now, and I just kind of want to walk through and make sure we're all on the same page as far as where things are deployed and what actually looks, what I'm actually going to be logging into. So I'm looking at the NSX-T UI, and I'm looking at a very simplified network diagram of the NSX-T deployment that I have today. So this NSX-T deployment is linked to a vCenter, and that vCenter is what's actually going to be used by my Horizon connection server to build out the virtual desktops. So it's linked to what's called, and we have this here, this Horizon segment site 2. This is my second site. So all the virtual desktops that are actually built out and created by Horizon are going to be put on this, this site 2 segment. So we can see right off the bat that we have pretty good visibility into what is actually being built in the environment. And you can see that NSX, our network fabric, has really good insights into what's actually going on. This is very different from a normal or traditional network topology where the network actually has no idea what the workloads are themselves. They only address them by MAC address and IP address. So you don't really have this sort of insight that you can invoke policy based on in a normal network topology. But because NSX is integrated with vCenter in this instance, we're able to gain these insights and use them to our advantage. So what I've done over here, if I go over to the system settings and then I go into my fabric, I can just show you that I am linked to the vCenter. That's how I'm pulling in this information for what's actually built onto the environment. So I'm linked to this vCenter here, and this vCenter is registered to version 7.1, which is not really important for this demonstration, but it's good to know, I guess. And then we have our vCenter, we have the inventory, we know what virtual machines are applying to, and they're all running on our NSX-T base segment. So the next thing NSX has to do is be able to connect to our Active Directory environment. So I have 2 domain controllers that are running DNS and everything like that in my environment. I've connected NSX to that, and I've started syncing Active Directory into my NSX-T environment. So because of this, now the next step, so now I have my ability to identify users. So my next step is to go ahead and create groups that I can then make that information more valuable to my security fabric. So what I have here is 2 groups. I have one that's called Horizon VDI 01. And if I took a look at what's actually in this environment, I can see my group definition is based on an AD group. And this AD group is actually pulled directly from my Active Directory environment. So I can see where it actually lives in the OU structure. And so any users that are part of this Horizon NSX security OU or group within Active Directory, I can use to then create groups and create policy based on that user identity. So just shows an example. So if I were to edit this and I wanted to add more user groups, I can simply go here, and I have now, it's pulling this list directly from my actual Active Directory environment. So we can see that NSX is now integrated not only with our compute infrastructure, but also our identity provider infrastructure as well. And when you have those 2 things in tandem for a network infrastructure, you're able to apply security as a whole that is much more context aware than what's traditionally shown in a lot of these environments. So the final thing within NSX, there's a lot of security here, and we can, if anybody's curious about these other security components within NSX and how we can use them in different environments, obviously contact us and we can talk through this. But what we're focusing on today is this distributed firewall. And this is the firewall, again, that is focusing on east-west security. So each one of these rules that I have created here are going to be applied directly on the virtual machine itself. So every VM inside your environment is going to have a firewall directly on the VM NIC. In our case, every virtual machine is a virtual desktop. So that means that all of these rules are going to be applied on a per virtual desktop basis. And so what we have here is a simple rule that I'm going to deploy. My source is the group that we just created, this Horizon VDI group. So any user that's going to sign into a desktop, and then the NSX-T thin agent used by VMware tools is going to identify the user that's actually logged into it. It's going to alert NSX-T, and NSX-T will now know to apply this policy to the desktop associated with that person. Our destination here is a very simple group. This is just IP addresses that I have. And this is to show an example of say that my user logs in who's a part of this Horizon group. And I don't want him to access, or him or her to access, these 2 IP addresses. So say these are critical infrastructure, say that you have several implementations of infrastructure that you're using and you want to limit access to these. In my case, I'm just using these 2 IP addresses, which happen to be the vCenters deployed. So right now I'm going to allow this connection. And so going through this overview of NSX-T, that's kind of what it looks like from a perspective of the infrastructure admin or the network administrator who's actually applying the security policy on a user basis. Now, if you look over at let me get rid of this. If you look over, I'm looking at a remote desktop that I'm using to connect to my actual virtual desktop. So what I do here in this environment is I'm going to go ahead and I'm clicking on, you have the option of either using a web-based access into the Horizon connection server, or you can use a client. So here I'm using this client. I open up this client and I'm connected to my Horizon GSLB connection server, which if we refer back to that diagram we showed earlier, this is basically a GSLB across multiple sites. So that's why I'm presented with 2 different sites of connection service to deploy into. So as a user, I have the option. This is the policy that you can build out. Based on my user account, I'm allocated desktops in either site, but this can also be used as a failover scenario where you only have 1 desktop pool and the users don't really need to care where they're located. It just matters where you have capacity at the time. And because you don't have to worry about the location of the machines they're deploying, you only have to care about the user identity in this context. So regardless of where I choose these sites, as long as my NSX implementation is either federated or spanned across both sites, the policy remained the same. So when I look back in here and I go ahead and so now I'm logged into my NSX-T, or not my NSX-T, but trying to figure out how to hit Control-Alt-Delete. I'm logged into my VDI desktop here, and I'll just go ahead and re-log in. So I'm logging into this with my account. So now what I'm looking at here is I'm a user. I just connected. I was using, say that, for example, is a thin client, and now I'm connected to my VDI environment, and I'm located inside of my data center. So now I'm running on a virtual machine that's located inside my data center, which means that my administrators, in this case, have full control over what's going on in this machine. And my user account, this Billy.Downing user account, is a part of that group that we created earlier, the Horizon group within Active Directory. So those rules will apply to my user account as well. So I just want to make sure that I can ping this address. So this is one of the vCenters, and say that in this instance, I'm a user and I shouldn't have access to this. I shouldn't be able to reach this IP address. In this case, it is a vCenter, right? So rather than having to try to track down the IP address of my actual virtual machine and have the administrator block this subnet or block this entire subnet or this specific IP address, because perhaps right after me, an actual administrator will log on to their VDI environment and they do have to access those. So if you block this entire subnet, now you have an issue where you have to then segregate your desktop pools for Horizon based on user responsibility, rather than just applying rules directly to user responsibility. So it kind of just saves you a step in understanding the identity and giving NSX that context. So right now I can ping this address. So let's go ahead and change that. Let's say, wait, this user, part of this group, should not be able to access that. So I come back over to NSX. I have this group already created, or this rule rather, this Horizon to vCenter. And this is my group again, that is my Active Directory account. I'm going to go ahead and just change this to drop traffic. So I'm going to publish this, and what this is actually doing is going out and applying this rule set to any applicable virtual machine that is required, that this is actually relevant to. So because my user account is identified in NSX through the VMware tools, and NSX is aware that the virtual machine that I logged into from my VDI desktop is part of this group, this set of rules will be applied to that virtual machine itself. And then if all goes well, my user account, a part of this group, should no longer be able to access the vCenter. And it looks like I don't have access anymore. So if I were to log in as an account that didn't have that rule applied to it, or I was a part of it, say an administrator's OU or some other group that wasn't explicitly called out in NSX, I would be able to access that. So all in all, what we've kind of demonstrated here is the ability to control traffic flow sourced from the actual virtual desktop based on user identity. So what this, if I were to kind of just do a summary here, let me pull this back up. So if I were to do kind of a summary of what we went over to keep this under 30 minutes. So the solution overview here is that we took a look at Horizon. We took a look at a few of the different components that we can deploy in our environment to enable a VDI infrastructure, a virtual desktop infrastructure, to enable our workforce to use thin clients or other means to access data center assets, and still give the administrators complete command and control of that environment. Using NSX-T, we're able to provide more context to the actual network fabric itself to provide security policies, load balance, any sort of network functions that we need based on user identity and the user role themselves, rather than the resources they're actually consuming. So what this is doing essentially is cutting out the middleman. So instead of having to have some sort of centralized entity that can identify workload to user and then apply the user role and then apply rules to those user responsibilities, we can cut out all the information and provide it directly on top of our network fabric, because NSX-T in this instance has context-aware firewall based on the identity of the user. So therefore, we can tie responsibility directly to user access across our entire environment, regardless of location, regardless of time, regardless of anything about that user. If they change, if the infrastructure changes, it doesn't really matter, because the rules are applied to the user themselves. And that's kind of the end goal of what we want to be. We don't want to worry about managing infrastructure. We want to be managing security from the base level that we can. And with that, that's all that I have. So if there are any questions, we can go ahead and talk through those now.
Hey, Billy, great job on this demo. Really appreciate the time. We do have a couple questions. So the first question here is, can the Active Directory group you are referencing, Horizon NSX-T Security, contain other groups, or should it only contain user accounts?
Oh, no, so it will be, you're talking about like nested groups? Absolutely. So you can create a group of VMware administrators, and then within that group have a series of other groups of users based on location or so forth. And with that, you can still, the goal that NSX is doing here is trying to glean the IP address based on the user account that's actually using that IP address. Once it has that information, it can look up, what group you're a part of from there.
Perfect. Thank you, Billy. Another one here, can the NSX identity policies be stretched across multiple sites?
Yes, of course. And that's another part of this. So if you have multiple sites, like for example, in this environment, I do have multiple sites. There are two different ways that you can stretch policy across. You can either use, if these two sites are in sort of a metro cluster type environment where there's low latency, you can use what's called NSX multi-site, which you have a single control plane for both sites, and you just distribute those NSX control nodes across the two sites. In that case, any sort of policy you create will obviously be replicated in either way, or in either site rather. And so that would be one way to do it. Another way is if you have disparate sites, so you have sites that are geographically separated, beyond 100 milliseconds or something like that, and you can't spread the control nodes across both sites and have them communicate effectively. You can use what's called NSX federation, and what that does is provide an overarching control plane, so that when you invoke policy, that policy is distributed across all of your sites in a simultaneous fashion. So it essentially federates all of your policy across multiple sites. So yes, you can absolutely do that.
Excellent. And then our last one here, how does NSX lock down the actual endpoint from other types of attacks when a user is in their session?
Yes, so that is more tailored for malware protection, antivirus, and things like that. And VMware actually, works has acquired Carbon Black some time ago, and Carbon Black is integrated directly into NSX. So for a full suite of end user protection, NSX will still be that central point of control, command and control for your network fabric. And with something like antivirus and malware, you can utilize Carbon Black as your identity protection and endpoint protection on a virtual machine basis. So that's how you can kind of accomplish that. And you can still use that in tandem with identity firewalling to ensure that, you have security policy like firewall rules and things like that on your fabric based on user. And then based on each virtual machine and user account logged into it, you can use Carbon Black for a full endpoint protection solution.
Excellent. Thank you so much, Billy. And thank you everybody for joining us today. As Billy mentioned earlier in the demo, we do a power block every Wednesday. So for the list of all these scheduled power blocks, feel free to go out to sterling.com and go to the calendar tab on the website and register for any of the upcoming power block sessions that we have going on. If you'd like to contact anyone that was on the demo today, the contact information is on your screen for Megan Moore, Mark Dunn, and then our general connect@sterling.com. We thank you again for your time, and please let us know if you have any questions at all. Have a great day.
Awesome. Thank you.